Mathematics at its core is a profound human endeavor that has fascinated philosophers and scholars for centuries. The nature of mathematical entities and their existence has been a subject of intense debate, leading to the development of various philosophical perspectives. This is merely my effort to kind of explore three primary viewpoints: mathematical Platonism, mathematical nominalism, and mathematical fictionalism. Each of these perspectives offers a unique lens through which to understand the abstract world of numbers and mathematical truths. Mathematical Platonism posits a metaphysical view that mathematical entities exist in an abstract sense, untouched by human thought or physical reality. According to Platonists, numbers are not mere symbols scribbled on a blackboard. Rather, they are timeless entities residing in an abstract world, existing independently of our minds and the universe itself. This perspective suggests that mathematical truths, such as the infinite nature of prime numbers, reflects a reality that is objective and unchanging, far removed from our spatio-temporal world. Platonists, often dubbed realists, assert that these abstract entities form the bedrock of mathematical practice. They argue that the logical structure of mathematical theories must refer to actual mathematical entities, which are not mere figments of human cognition or physical manifestations. Such a stance provides a straightforward explanation for the objectivity and consistency of mathematics, distinguishing it sharply from the mutable and contingent spatio-temporal realm we inhabit. To fully grasp mathematical Platonism, one must simply understand what kinds of entities populate the abstract realm of mathematical ontology. Traditional Platonists or objective Platonists argue that these entities are objects in the most general sense. They are not everyday objects but abstract ones like numbers, sets, and geometrical forms, which exist independently of the physical world and our rational activities. Additionally, structural Platonists suggest that the fundamental entities of mathematics are not just objects but structures. According to this view, individual mathematical entities are positions or roles within these structures. This perspective shifts focus from the objects themselves to the interrelationships and the framework they form. But let us not get buried in a truckload of words. What does it mean for a mathematical entity to be abstract? Abstract entities are non-spatial temporal. They exist outside the bounds of space and time. They are also acausal, meaning they neither influence nor are influenced by the causal chains of the physical world. Many philosophers further ascribe to them attributes like eternality, existing at all times or outside time altogether, changelessness, and necessary existence. Independence, another cornerstone of Platonism, suggests that mathematical entities would exist and retain their properties even if there were no rational beings to think about them. This implies a radical autonomy of mathematical reality from human cognition and physical processes, reinforcing the idea of an objective and immutable mathematical realm. So I've gone back and forth on this on this same idea. But I think let's break it down by simply saying mathematical Platonism offers a rich and enticing view of mathematics as a domain of abstract eternal truths. It faces challenges though, but also provides a compelling framework for understanding the profound and objective nature of mathematical knowledge. Some limitations could include things like the belief in an abstract realm of mathematical entities requires a significant metaphysical commitment, which many find difficult to justify. Another limitation is explaining how humans can access or know about these abstract entities remains a challenge. And then there's the issue for the causal connection. There's a lack of a clear causal connection between the abstract mathematical world and the physical world we experience. With that said, let's get into mathematical nominalism. Nominalism is the take that mathematical objects like numbers, sets, and circles don't actually exist. Normalists are cool with saying there are things like piles of 3 eggs or ideas of the number 3 in people's heads, but they insist that none of these things is the number 3 itself. If the number 3 existed, it would be an abstract object. But here's the kicker. Normalists don't buy into the existence of abstract objects at all, so they don't believe in numbers. However, we must navigate some nuances. Firstly, some theories suggest mathematical entities must be mental constructs. But normalists reject the idea that these entities exist as abstract objects independent of human thought or language. To appreciate this, consider the division of reality into concrete and abstract categories. Normalists assert that abstract objects, which are non-spatial, necessary, unchanging, and acausal, simply do not exist. Examples of concrete objects include stars, humans, molecules, and even theoretical entities like electrons and dark matter. In contrast, abstract entities are those like universals and properties, which do not have a physical presence. Let's break it down even slightly more easily. The idea that things like numbers and shapes, like the number 5, don't actually exist on their own. Instead, they are just concepts we use to describe the world around us. Here's one way to think about it. You can see and touch 5 cans of mosi on a table, but can you see and touch the number 5 itself? Obviously not, right? You can't see or touch it. Normally say that while you can have 5 of something, like 5 basketballs, apples, or pencils, the number 5 is just an idea in your head, not a real thing out there in the world. Mathematical nominalism is the idea that numbers and other mathematical objects aren't real. They're not real things, just useful ideas. Different types of nominalism explain this in various ways, but the core idea is the same. Math is a tool we use to understand the world, not a collection of real abstract objects. Some limitations perhaps could be explaining the apparent objectivity and consistency of mathematical truths becomes problematic under nominalism. And then the other limitation could be perhaps the effective application of mathematics in describing physical phenomena suggests an underlying reality that nominalism struggles to kind of account for, Fictionalism in the philosophy of mathematics is like saying math statements like 2 + 2 = 4 and the square root of 9 is 3 are just stories we tell. If we take them literally, they are actually false. Why? Because these statements suggest that numbers and mathematical objects are real things, and fictionalists believe they are not. Think of it like this. Just as Harry Potter is a wizard is true in J.K. Rowling's story, but not in real life. Math statements are true in the story of math, but not in reality. Fictionalists reject the idea of abstract mathematical objects, making them a type of nominalist or anti-realist. This contrasts with mathematical realists or Platonists who believe that mathematical statements are true and refer to mathematical objects. Fictionalism is different from other nominalist views that reinterpret mathematical statements to be true without involving mathematical objects. Instead, fictionalism suggests that while we typically see these statements as true, we are mistaken because they imply the existence of non-existent objects. Despite this, fictionalism does acknowledge a kind of truth in the narrative of mathematics. So while 2 + 2 = 4 might be false in a literal sense, it's true within the math story, just like how wizards exist in the Harry Potter story. A big perk of fictionalism is its simplicity. There's nothing mystical to know beyond the human-created math story. Learning math is just about understanding this story. However, a major challenge for fictionalism is explaining how math, unlike fiction, is so crucial to science and everyday life. Some argue this necessity implies that mathematical objects must be real. Some limitations for fictionalism could include things like utility in science. Explaining the crucial role of mathematics in scientific theories and everyday life remains a significant challenge. And then there's also internal consistency. While fictionalism provides a consistent narrative, it struggles to account for the practical and seemingly indispensable nature of mathematical truth. And then there's also philosophical acceptance. Many find the idea that all mathematical statements are ultimately false to be counterintuitive and difficult to reconcile with the success of mathematics itself. Among these perspectives, mathematical nominalism offers a balanced and practical approach, and a pragmatic one too. It's in my undistilled opinion, because I feel like it kind of acknowledges the utility of mathematical concepts without committing to their independent existence as abstract entities. This view aligns well with the practical and conceptual aspects of mathematics, providing a coherent framework for understanding mathematical truths as human constructs that effectively describe the real world. Mathematical Platonism offers an enticing vision of an abstract realm of eternal truth, Its practical and its metaphysical and epistemological challenges make it less compelling. On the other hand, mathematical fictionalism, while simplifying the philosophical landscape, struggles to explain the indispensable role of mathematics in science and daily life. Thus, I strongly feel mathematical normalism stands out as a reasonable and practical position to take, because it kind of emphasizes that mathematics is or operates as a human endeavor that serves as a powerful tool for interpreting and navigating the complexities of the physical world that we find ourselves in. But you think through this, and do let me know what you think, and do let me know if you think numbers exist and if math is invented or discovered.